everyone! Today we're diving into the fascinating world of triangles. Let's start by understanding what exactly a triangle is. A triangle is a polygon that we create by connecting 3 points. Watch as we build one step by step. Now we connect these 3 points with straight lines to form our triangle. Each connection creates a side of the triangle. Every triangle has 3 key components. It has 3 sides, 3 angles where the sides meet, and 3 vertices, which are the corner points. Now here's the most important rule about triangles. No matter what triangle you have, the 3 interior angles will always add up to exactly 180 degrees. Let's verify this with our triangle. When we add up all 3 angles, we get exactly 180 degrees. This is true for every single triangle that exists. Triangles can be classified in 2 main ways. We can group them by their sides, looking at whether the sides are equal or different lengths. We can also group them by their angles, checking if they're sharp, right, or wide angles. In the following sections, we'll explore each of these triangle types in detail. You'll learn to identify them like a pro and understand what makes each type special and useful in the real world. Now we explore equilateral triangles, one of the most special and symmetrical shapes in geometry. An equilateral triangle has a unique property that makes it perfectly balanced. The defining characteristic of an equilateral triangle is that all 3 sides are exactly the same length. No matter which side you measure, you'll always get the same result. But here's what makes equilateral triangles truly remarkable. Not only are all the sides equal, but all the angles are equal too. Each angle measures exactly 60 degrees. This perfect symmetry means that if you rotate an equilateral triangle by 120 degrees, it looks exactly the same. It has 3 lines of symmetry and rotational symmetry. You can find equilateral triangles everywhere in the real world. The most common example is a yield sign, that familiar red and white triangular road sign. Equilateral triangles are also found in architecture, art, and nature because their perfect balance and symmetry create strong, stable, and visually pleasing structures. Remember the key properties of equilateral triangles: all sides equal, all angles 60 degrees, and perfect symmetry. These properties make them fundamental building blocks in geometry and design. Now we explore isosceles triangles, which have a special property that makes them quite interesting and useful in geometry. An isosceles triangle has exactly 2 sides that are equal in length. These equal sides are often called the legs of the triangle, while the third side is called the base. In this example, sides AB and AC are both equal. We can see this clearly with the matching marks on each side. The base BC has a different length. Here's the remarkable property of isosceles triangles. When 2 sides are equal, the angles opposite those equal sides are also equal. These are called the base angles. Notice that angles B and C are both 67.5 degrees. They're equal because they're opposite the equal sides. This relationship always holds true in isosceles triangles. This gives us a powerful mathematical relationship. If we know that 2 sides of a triangle are equal, we automatically know that the angles opposite those sides are also equal. We can express this mathematically. If side AB equals side AC, then angle B equals angle C. This is one of the fundamental properties that makes isosceles triangles so useful in geometry and real-world applications. Understanding isosceles triangles helps us solve many geometric problems. When you see 2 equal sides in a triangle, you immediately know you're dealing with 2 equal angles as well. Now we come to scalene triangles, the rebels of the triangle world. These triangles are completely unique because all 3 sides have different lengths, and all 3 angles are different as well. Here's our first scalene triangle. Notice how each side has a completely different length. No 2 sides are equal. This is the defining characteristic of scalene triangles. The angles are also all different. Unlike equilateral triangles where all angles are 60 degrees or isosceles triangles with 2 equal angles, scalene triangles have 3 completely unique angles. Let me show you several different scalene triangles to demonstrate their variety. Each one is completely unique in its proportions. Here we have 3 very different scalene triangles. One is tall and narrow, another is wide and short, and the third has an irregular shape. Despite their differences, they all share the same property: no equal sides and no equal angles. The key properties of scalene triangles make them the most diverse type of triangle. Let's summarize what makes them special. First, all three sides have different lengths. No two sides are ever equal. Second, all three angles are different. There are no equal angles in a scalene triangle. Third, scalene triangles have no lines of symmetry, unlike equilateral and isosceles triangles. Finally, this means each scalene triangle is completely unique in its proportions. Here's a practical example. Imagine a triangular plot of land with sides measuring 15 meters, 23 meters, and 31 meters. This would be a scalene triangle because all sides are different. Scalene triangles are everywhere in the real world, from irregular roof sections to triangular garden plots. Their lack of symmetry makes them perfect for situations where you need a triangle that fits specific, unequal measurements. Now we switch gears and classify triangles by their angles. First, we have acute triangles. In an acute triangle, all three angles are less than 90 degrees. Every angle is sharp and pointy. Here's our first example of an acute triangle. Notice how all three angles are less than 90 degrees, 70 degrees, 60 degrees, and 50 degrees. Each angle is sharp and pointed because they're all acute, meaning less than 90 degrees. Let's look at another example to see how acute triangles can have different shapes while still maintaining this key property. Here's another acute triangle with different proportions. This one has angles of 80 degrees, 55 degrees, and 45 degrees. Even though this triangle has a completely different shape, it's still acute because every single angle remains less than 90 degrees. The key characteristic of acute triangles is that they appear sharp and pointed at every corner, with no wide or square angles. Remember, acute triangles have all angles less than 90 degrees, making them appear sharp and pointed at every corner. Right triangles are one of the most important types of triangles in mathematics. A right triangle has exactly one angle that measures 90 degrees. That's a perfect corner, like the corner of this page. This 90-degree angle is what makes the triangle right. The small square symbol in the corner is the standard way to mark a right angle in geometry. In a right triangle, we have two shorter sides called legs and one longer side. The longest side, which is always opposite the right angle, has a special name, the hypotenuse. The hypotenuse is always the longest side of a right triangle. This isn't just a rule we memorize, it's a mathematical fact that comes from the geometry of right angles. You can see right triangles everywhere in the real world. Think about the corner of a book when it's open, or a door that's half opened against a wall. These create perfect right angles. Right triangles are especially important in trigonometry, where we use them to understand relationships between angles and sides. They're also fundamental in construction, engineering, and many other fields. Finally, we have obtuse triangles. These are triangles where one angle is greater than 90 degrees, making it wider than a right angle. Here we can see an obtuse triangle. Notice how angle A measures more than 90 degrees. This obtuse angle is what defines this type of triangle. You can find obtuse angles in everyday life. Think about a partially opened door or a reclined chair. These create obtuse angles just like in our triangle. When a door is partially opened, it creates an obtuse angle with the door frame. This angle is greater than 90 degrees, just like in our obtuse triangle. Similarly, when a chair is reclined, the angle between the seat and backrest becomes obtuse. This comfortable position creates an angle greater than 90 degrees. The key characteristic of obtuse triangles is that they always have exactly one angle greater than 90 degrees, while the other two angles are acute, meaning they're less than 90 degrees. Triangles are everywhere around us. From the structures we build to the objects we use daily, triangles play a crucial role in design, stability, and functionality. In architecture and engineering, triangles provide incredible strength and stability. Bridge trusses use triangular shapes to distribute weight evenly. Building roofs are triangular to efficiently shed rain and snow. Communication towers rely on triangular supports to withstand strong winds. Triangles also appear in everyday objects and signs that we encounter regularly. Traffic signs like yield signs use equilateral triangles for their distinctive shape. Staircases naturally form right triangles in their profile. Even pizza slices are typically cut as isosceles triangles for equal portions. Now let's review the key takeaways about triangles that will help you in your mathematical journey. Here are the key takeaways to remember. All triangles have angles that sum to 180 degrees. Triangles are classified by their sides as equilateral, isosceles, or scalene. They're also classified by their angles as acute, right, or obtuse. Understanding triangles builds important spatial reasoning skills that help with problem solving. And triangles provide incredible strength and stability in real-world structures. Keep exploring and connecting these triangle concepts to the world around you. Every time you see a bridge, a roof, or even a slice of pizza, you'll recognize the mathematical principles at work. Understanding triangles is truly the foundation of geometry and spatial thinking.